Okay, what's up? What's poppin'? How's it going? Merry Christmas. I have my Christmas little thing on, or whatever holiday you are celebrating or not celebrating this season. Regardless, happy holidays. So I did my unit plan on quadratic equations. Super fun, super juicy, for Algebra 2. And it's actually something that has a lot built into it, and we did this stuff really quickly. So we did factoring, like all the factoring in 2 days. So this is like the second day of factoring that I taught. Then after that, we moved to complex numbers and introduced them to complex numbers and did like all those operations and stuff in a day. And then we did completing the square, which is, I know, a favorite of truly everyone. And then we did the quadratic formula once we had all those tools, just to kind of set up kids with a good toolkit for dealing with quadratic equations. Um, some of the things that were my favorite parts of this, I started off with the dot talk because I found that with factoring, a lot of the issues that these kids have is not actually the process of factoring, but it's actually literally just remembering multiplication. And so I started off with a dot talk and we like kind of reviewed like, oh, why do we think multiplication works like this? Like how does this work? And just kind of get those kids thinking in like a very multiplication way, so that they can have that thought process as they go throughout a lot of the factoring stuff with quadratic equations. So complex numbers and operations, I wasn't actually there for that day. I planned for it, but Wilk mostly taught that day. Completing the squares the day I want to focus on. I really had trouble with completing the square truly until I didn't get it until during my sophomore year of college. I was tutoring students in Calc 1 and teaching them conic sections. And I was like, oh, you complete the square for conic sections. And then I was like, wait, I get it now. And it was like a crazy moment for me. But hopefully, I was just trying to think of ways to help kids get it before their sophomore year of college, which honestly would have been ideal. So what I did was I made this little completing the square slide deck, and I was really thinking through a lot of the tools we've been given in this class and previous ed classes, and I really liked the idea of using concrete representational abstract, which is basically where you start with like tools and like visual or like tangible manipulatives, and then you move to like an image representation, and then you move to actually doing the math after that. And so it's this idea that you have like a grasp of what is actually happening, like you can see it, you can touch it before you move on to like what that math is just representing. And so I made this little, oh wait, this is the last slide. Hold on. I made this little Google slide and I'm really proud of it, not gonna lie. But it is completing the square with algebra tiles. I think I'm funny. I don't think the high schoolers do, but that's okay. Um, but I kind of wanted to incorporate algebra tiles. Obviously, we're online, so I made online algebra tiles, which there is an online algebra tiles resource, but it's like kind of gross. I think they could use some improvement in the way that they've kind of organized it. It's cool, but like I just think it could be cooler, you know? And also I just like the aesthetic pastel colors that I choose. I don't know. Anyways, so I know that a lot of my students really had much experience with algebra tiles before. And so I kind of wanted to start out with an introduction. And so for you guys, I'll just also do a quick introduction just in case. I know we went over it during one of our classes with Dr. Amick, but I'm not exactly sure when that was. But if you're unfamiliar, algebra tiles are kind of like those base 10 blocks where you have cubes of 1, sticks of 10, and then blocks of 100. But now they're representing x squareds, and 1. An x cube would be like a physical cube, but it's actually a really cool way to envision certain like units, I guess, because you can multiply them and their areas represent what they get, right? So if you set it up in kind of this like box method, so outside the box you have x times x, and then your area inside the box is x squared. And so this is super fun when it comes to factoring and even multiplying binomials, because you can just set up your factors on the side. So x plus 1 times x plus 2, and then you would get, okay, an x squared, and then 1 times x is just x, 1 times x is just x, and then on the same thing here. And then you could just count up what's in the box. So we get x squared plus x plus x plus x plus 1 plus 1. So that's x squared plus 3x plus 2, which is, in fact, x plus 1 times x plus 2. So it's a really fun tool. I know you can also use algebra tiles to solve equations. I really haven't had much experience with that, but I really love it for completing the square because you actually complete an actual square. It's amazing. So we then walked through factoring, and this was like an activity where you can totally like move things. So like this slide, I played with it a bunch since then, but the slide originally looks like all these things are on the side, and you just have what's inside the box. And you say like, okay, what lines up on the edges, and you can just like factor it this way. So they're gonna be like, oh, an x has to go up here because there's like this really long stretch, and there's an x squared, so we have to have x times x, and we have to like drag our ones here and our ones here. Oh, we're so close. There we go. And so, okay, so when we factor x squared plus 4x plus 3, we get x plus 3 times x plus 1. And when I did go through this with the students, we actually like ended up doing the factoring. Like I would annotate the screen and we would do the factoring that Mr. Wilkinson does, which I hate because I think it teaches bad math, but that's just me. Anyway, so I would like then do this problem by factoring and show them like, okay, here's the like representational like side of it, and here's the actual factoring with numbers. So super fun stuff. So I was like, hey, did you get it right? So then, of course, kind of in an almost like inquiry kind of way, I said, okay, now what do we do with this one? Like we can't factor it, and if we tried, we have 1 times 1 here, but there's no block here. And so we see we are actually unable to factor it. And so students kind of played with that, but then like got to the point where they're like, I'm really confused. I'm like, it's because you can't factor it. And so going to the next slide, we can't factor it, but what can we add to our box to make it factorable? And so this is when I brought in like adding algebra tiles. So we can add 8 ones. And when we do that, we get a perfect square, like a actual perfect square. And now we can factor it. So that's going to be x plus 3 and x plus 3. And so whenever they had orange blanks here, they filled it in themselves. And so then we kind of went through a, hey, like, what do we notice? What are we seeing? What are we wondering? And I kind of wanted to like get to understanding that it's always going to be a square when we complete the square. We're not usually going to get many rectangles when we complete the square because it is going to be something that we solve using square roots. And the second thing that I wanted to get out of kind of our exploration with these was that the number we need to add to complete the square will always be b over 2 squared. And so I think really working through like, this is why, because we need this little cube, like this little box here, got us to this instead of just like saying, here's the formula. I'm not going to tell you why. Too bad, like sucks to suck. I think it was really helpful to kind of get there. And so now that we had done it with algebra tiles, I did like a full example together with actually just doing the math. And so we kind of worked through it. There was like blanks and then color-coded steps. I talked about moving our constant term over first because when you initially learn how to do it, that's going to be easier. Though technically, when you do it with the algebra tiles, you don't have to take out all the ones and then add back in however many you need. And so that was something that I definitely could have explained a little bit better with like, oh, when we use algebra tiles, like moving the constant term over would be the same thing as taking all your ones out and then replacing it with what you need. But I still think it got the point across. And unfortunately, the examples in the book both had complex answers. And so it was a little bit difficult. So you had to introduce like the negative algebra tiles. And so we like subtracted 4 from both sides eventually just to get 4, or either that you take all of them away and then just add 4. Either way, so on these, I let them do it themselves. So they were given a copy of this slideshow and they were just told to complete it. Um, and so they did this one and then they did the next one. And these were both the same examples that were in their workbooks that the rest of the PLC was doing. And so they were able to kind of like work through in their Envision workbooks and Envision homework and stuff, the same things. I also kind of connected it to what we had learned about vertex form at the end there, just because we do have something nice plus something else. But a lot of them got a little bit confused by that. But it was kind of a bonus question just to see if they got it. Anyways, this is what I did. I think it was super fun, super cool, and I actually really enjoyed making it. My fiance used it for his classroom, and a bunch of students were helped by it, which makes me feel really good. So yeah, hopefully I can actually use real algebra tiles when we're not in a pandemic. But for now, this was pretty dope. Anyways, have good holidays, you guys. I miss you all, but I'll see you in January. Bye.